Carnegie example. Okay, we have x cubed plus 3x squared minus x minus 3. And Colt has worked through this problem and done step by step. Okay, and we're going to explain what he did. Okay, in this first step, he took out an x squared, and he has x plus 3 minus 1, parentheses, x plus 3. What would we call this first step? Okay, another way of saying that though. Grouping. Okay, so he factored by grouping. Okay, so look at where he started, and then his next step. Yes, he took out that GCF, but we call that factored by grouping. Okay, step 2. He has x plus 3, x squared minus 1. What would you say there? Okay, simplified to what? Like, what did he simplify? What did he do?
Took the x squared minus 1 from the grouping and put it into...
Okay, so he rewrote his factors, right? Okay, then you have x plus 3, x minus 1, x plus 1. What did he do from step 2 to step 3? And what do you call that? Difference of squares. Very good. So factored x squared minus 1 using the difference of squares. Okay, so in factored form, then we have x plus 3, x minus 1, x plus 1. And it wants us to identify the degree of each factor. What would the degree be of each factor? 1, 1, and 1. How did you know that they were all 1? Okay, there's not necessarily that there's no exponent. They're all to the power of 1. Okay, so you don't have an x squared or an x cubed or a quartic, etc. In the factored form, x plus 3, x squared minus 1, what would be the degree of each factor? 1 and 2. Okay, so again, just making sure that you know how to identify your degrees. Questions on Colt's little worked out example? Okay, so the first way of factoring we're going to look at is factor by grouping. Okay, when do we use it? Okay, you use factor by grouping when you have 4 terms. Okay, and the ratio of the first 2 terms has to be equal to the ratio of the last 2 terms. Okay, 4 terms only. Okay, not 5, not 3, 4. Okay, and it's the ratio of the first 2, and it has to be equal to the ratio of the last 2. Okay, and what I mean by that is, what are your coefficient ratio of your first 2 terms? 3 over 1. Okay, what is the ratio of your second 2 terms? Negative 3 over negative 1. Do they simplify to the same thing? Yes, they're both what? 3. Okay, so that's one of our qualifications. And then the other one is that there's 4 terms. Do we have 4 terms? Yes. Okay, so we have 4 terms, equal ratio, so we can proceed with factor by grouping. Okay, so just like we did with quadratics, split your river. Okay, what is the GCF of my first 2 terms? X squared. What am I left with in parentheses? Very good. Okay, take the sign of what you split. Okay, what is the GCF between 3x and negative 1? Okay, and what am I left with inside? Okay, what are my 2 factors? Okay, Within those factors, is there anything that can be simplified further?
Yes.
What? X squared minus 1 because it is a what? Difference of squares. So how is this really going to factor out?
X minus 1, x plus 1, 3x plus 1.
Awesome. And that's all there is to it. Okay? But you have to, again, make sure you have 4 terms, make sure your ratios are equal, and the last thing is when, as you're factoring, make sure you don't have any difference of squares at the end, okay, or any GCFs that you can take out. Questions on example 1? Yes? We have what 2 ratios? 10 over negative 6 and negative 5 over 3. Do those simplify to the same thing? Yes? Okay, so we can proceed with grouping. I'm going to draw my river. What is the GCF of my first 2 terms? 2x squared. What am I left with inside? Take the sign that you destroyed, negative. Okay, and what is the GCF over there? 1. And inside I'm left with? Very good. Okay, what are my 2 factors? Okay, do I have any difference of squares or GCFs? Yes, no, maybe. No, 2x squared minus 1 is not a difference of squares. 2 is not a perfect square. Okay, so you would be done. So just make sure that you don't fall for this. This is not a difference of squares. Okay, number 3. What are my ratios? There's 5 terms. Very good. Okay, 5 terms, so it is not a special case, and we cannot factor by grouping. Okay, so your final 2 steps is always to double check difference of squares. And double check GCF. Okay, so when you're factoring, your last 2 steps is always going to be make sure there's no difference of squares, make sure there's no GCF. And what I mean by that is, let's say this factored hypothetically to 2x squared minus 2, 5x minus 3. What can you take out? 2. So it would really be 2x squared minus 1, 5x minus 3. And then what happens when you do that? You have a difference of squares. So then you have to just keep going. Okay, but if you don't take out that 2, you probably aren't going to recognize that there was a difference of squares. Okay, so just double check for GCF and then double check for difference of squares. This was just hypothetically speaking. Questions on the first page? Sweetness. Alright, I'm going to give you 2 minutes to compare the 2 work samples. You have Edina, I don't know, and Drew. Okay, and figure out which student factored correctly. So look at both work samples and figure out which kiddo factored correctly. I'm going to give you 2 minutes and jot something down for an answer. Give me another minute. Make sure you have something written down. Alright, raise your hand if you chose Edna. Okay, raise your hand if you chose Drew. Raise your hand if you said both. Okay. Tim, why'd you say Edna?
Well, Edna, I saw she did the splitting at the very beginning and then grouped the two and then just finished it out. Meanwhile, Drew, I couldn't really follow what he was doing with all the brackets and extra stuff.
Okay.
I just really couldn't follow what he was doing.
Okay. I saw some people who raised their hand for Drew. Vincent, why'd you choose Drew?
We took out the GCF right immediately, we took out the X right in the beginning, so if we simplified, it would be easy.
Okay, so he took out the GCF immediately. And then Miranda, what'd you say?
I think they're both right because even though they did the GCF at different times, they still have the brackets.
Very good. Okay.
Thumbs up next to both of them.
Yeah.
Oh, way to use your context clues, Nathan. Alright, so I agree that both of them did it correctly. Okay, so Edna factored by grouping and then factored out the GCF versus Drew who factored the GCF out first and then factored by grouping. Okay, so both of them just did it different ways, but they arrived at the same solution. Okay, I personally think that it's easier to factor out the GCF at the beginning so that you don't accidentally make the mistake of forgetting at the end. But either one of them are correct. Questions on those work samples? Okay. The next one is probably the trickier one of the three. Okay, it's called U substitution. And the reason that we're using U substitution is for those of you going into pre-cal and upper level math. Okay, this will be extremely important for you. Okay, U substitution, we use it when there's three terms. Okay, and the ratio of the exponent of the first two terms has to be 2 to 1. Okay, and the last term must be a constant. So, three terms, ratios of the exponents are 2 to 1, and the last term is a constant. Okay, so, for example 1, do we have three terms?
Yes.
Yes. Do we have a ratio of our exponents being 2 to 1 in our first two terms?
Yeah.
And our last term is a constant?
Yeah.
Okay. So this is what we call U substitution then. Okay? We are going to make our U equal x squared. So we're trying to make this into a quadratic that we can factor and then substitute back in after. Okay, which is why it's called U substitution. Okay, so if I have U being x squared, okay, if I rewrite this then, that is x squared squared, right, minus 10x squared plus 9. Okay, now what can I put in place of every x squared? U. Okay, so really now I have U squared minus 10U plus 9. And do you see how we've now made this a quadratic? How are we going to factor this quadratic? You treat it just as if those U's were X's. What is it? U minus 9, U minus 1. Okay, very good. And now your last step is just to substitute back in. Okay, what did we say U equaled? X squared minus 9, x squared minus 1. Are we done? No, why? Which one? Both of them are difference of squares. Okay, so when we rewrite this, okay, what is the completely factored answer? Very good. Yes.
So we're just using U to like simplify the equation so we can factor it and then we put it back in.
But again, it only works if you have those degrees of 2 to 1 in the first terms, the ratio. And it has to be 3 terms. Okay, number 2. Okay, we have 2x to the 4th plus 8x squared plus 8. What am I going to want to do first? GCF. Okay, when I take out what? 2, what am I going to be left with inside? Okay. Do I have 3 terms?
Yes.
Yes. Are the ratio of my first 2 terms 2 to 1?
Yes.
Yes. Do I have a constant as my last term?
Yes.
Yes. Okay, so now I'm going to rewrite using u squared. So u equals x squared. Okay, I have 2x squared squared plus 4x squared plus 4. So when I rewrite, what is this going to look like? Very good. Okay, how does u squared plus 4u plus 4 factor?
U plus 2.
Okay, what's my next step? What are we doing? Substitute back in, so we have 2x squared plus 2, x squared plus 2. Do we have a difference of squares? No. How else could I also rewrite this?
2x squared plus 2 squared.
Very good. Ah.
Will U always be x squared?
Will u always be x squared? Yes.
Yes.
Questions on number 2? Okay. 3, what can I do? GCF of 2x. Very good. Okay, so what's my first term? X to the 4th minus 5x squared plus 6. Okay, do we have a constant now as our last term?
Yes.
Yes. Do our exponents have a ratio of 2 to 1? Yes. And do we have 3 terms? Yes. Okay, so I'm going to rewrite. I have 2x x squared squared minus 5x squared plus 6. I'm replacing x squareds with u. Okay, u squared minus 5u plus 6. I don't know why, but this is probably like the most misfactored degree, where with a coefficient of 1 that I see people do. Okay, what does u squared minus 5u plus 6 factor to? What is it? U minus 2, U minus 3. So many people pick 6 and negative 1. Okay, well that's negative 6. Okay. Substituting back in, so you have 2x, x squared minus 2, x squared minus 3, and can it be factored anymore? No, so you would be done. Ah. Yes.
Will we ever be given a situation where once we factor out GCF and stuff, our second isn't, like our second term isn't x squared?
Our second term isn't x squared.
Like if it just, we won't be able to put U in for it, or we have to do another step to get
It'll
it.
always be 4-2
It'll all be 4-2, okay.
for the purpose of this class, yeah.
Mhm.
Alright, number 4. 4x to the 4th minus 21x squared plus 5. Can't take anything out, okay? So, when I rewrite, I have 4x squared squared minus 21x squared plus 5. Okay, when I rewrite, what do you get?
So
4u squared minus 21u plus 5. Okay, what's different?
there's a coefficient on the U squared.
Okay, there's a coefficient on the u squared. Okay, I don't know about you. I'm not real sure how to factor that off the top of my head. So what are we going to have to do? Don't give me the answer. What are we going to do? Factor by grouping. Very good. Okay, so when you have a leading coefficient greater than 1, chances are you're going to have to factor by grouping. Okay, so you're still doing the same thing. Okay, you're still using u's, but now we have to factor by grouping. So I have 4 times 5, which is 20. I'm looking for the factors of 20 that will add and give me negative 21. Okay, so I have 4u squared minus 20u minus u plus 5. Split. What is the GCF of my first two terms? 4u. Inside parentheses I have u minus 5. Take the sign that I killed. What's going in parentheses? Okay, so what are my two factors? 4u minus 1 and u minus 5. Okay, what's my next step? Put in x squared. So I have 4x squared minus 1, x squared minus 5. Am I finished?
No.
Why? Very good. Difference of squares in that first term. Okay, so when I rewrite, what am I going to get? 2x plus 1, 2x minus 1, and x squared minus 5. Okay, so not necessarily difficult. However, you just have to remember that you can apply this rule. Okay, and then using u substitution with u being x squared. What questions do we have on u substitution? Nada? Can we move on? Are we good? Are we still looking at this? We're good? Yes? No? Okay. Thanks. Alright. The last special case is sum and difference of cubes. Okay, so your sum and difference of cubes. Okay, we use an acronym called SOAP. Okay, and it stands for same sign, opposite sign, always positive. Okay, so if you have the difference of cubes, okay, you'll have a minus b, same sign, minus, minus. And then inside you'll have a squared plus ab plus b squared. So you have same sign, opposite sign, always positive. Okay, and then for the sum of cubes, you'll have a plus b, a squared minus ab plus b squared. Okay, so always remember SOAP. Same, opposite, always positive. Got that? Okay, and the only way to use difference of cubes is by having two terms, and they both have to be cubes. Okay, so for instance, if I were to rewrite number 1 as cubes, okay, the first term would be x cubed minus, what's the cube root of 27? 3. So it would be minus 3 cubed. So notice how now I've written it in the form of a cubed minus b cubed. Okay, so what would a represent? X, and b would be 3. Okay, so now I have my a, I have my b, and I'm using the sum or the difference of cubes? Difference. So I'm using this first formula. So what would be my first set of parentheses? X minus 3. Okay, then I have a squared, which would be x squared, plus ab, which would be what? Plus b squared, which would be 3 squared, which is 9. And you're finished. Okay, this quadratic will never be factorable. I'll just write it up here. This quadratic and this quadratic will never be factorable.
So what did we just do with the difference? We like tried to factor it, but we can't go further than that?
We can't go further than this. This is your answer.
Okay. That's factoring a special case difference or some square
Of cubes.
cube.
Yeah. Okay, number 2, in order to write it as cubes, okay, how are we going to rewrite? What is the cubed root of 8x cubed? 2x. What is the cube root of 125? 5. Okay, so what would a be? 2x, b, 5. Okay, are we using sum or difference? Sum. So I'm using this equation. Okay, my first set of parentheses would be what? 2x plus 5. Second set of parentheses, I have a squared, which is, very good, minus a times b, which is plus b squared, which is, and you're finished. Questions on number 2? Perhaps the hardest part is just taking the cube root at the beginning. Okay, this is something that you do have to memorize. Okay, you will not be given these 2 equations on a test or a quiz or a progress grade. Okay, number 3. What is the cube root of 27x cubed? 3x. Minus, what's the cube root of 64? Okay, so what is a and b? Sum or difference? Different, so we're using our first equation. A minus b is going to give you what? Very good. Open up your second set of parentheses. A squared is 9x squared plus a times b plus b squared. Very good. What questions do we have so far? Okay, 4 gets weird just because there's 2 variables in this one. It's still treating it the same exact way though. What is the cube root of 125x cubed? 5x. What is the cubed root of 27y cubed? Okay, sum or difference? Sum. Okay, what is our a value? 5x, and our b value? Okay, so when we take a plus b, what are we going to get? Very good. Okay, then we have a squared, which is awesome, minus a times b, which is 15xy, plus b squared, Can you combine any other terms? No. And that is it. What questions do you have on number 4? Alright, before you try the practice problems on the bottom, alright, so this is your summary sheet. It's basically taking what was in the packet and putting it on one single-sided sheet. Okay, when to use factor by grouping, when to use U sub, and when to use SOAP, which is the sum or difference of cubes. Okay, factor by grouping again, 4 terms. Ratio of the first 2 terms is equal to the ratio of the last 2 terms. Okay, so in this case we have that 3 over 1 is equal to the negative 3 over 1. Okay. U substitution is 3 terms. Ratio of the exponents of your first 2 terms is 2 to 1, and your last term is constant, and you're using the fact that U equals x squared. And then the last one was sum or difference of cubes. Okay, this is kind of confusing. Right, so in your packet it's broken up what the sum is and what the difference is. So if you have the sum of cubes, if you want to write this down you can. You're going to have a plus b, a squared minus ab plus b squared for the sum. If you have the difference of cubes, it will be a minus b, a squared plus ab plus b squared. Okay, so same, opposite, always positive. So your b squared term will always be positive. Okay, and then your rewriting, to start solving these, you rewrite the cube roots. Okay, identify your a, identify your b, and then you're just substituting in. Okay, and the last and final steps is always to double check GCF and what? And difference of squares. Okay, it should always be your last step. What questions do we have? Alright, so we don't necessarily have an exit ticket today. However, you have 6 problems that were at the last page of those notes. Okay, so you are working these 6 problems. When you finish, you'll bring it to me. I will check them, and I'll send you back if you don't have 100, and you'll correct it until you get 100. Okay, so this is kind of your exit ticket. Okay, and then once you finish these 6 problems, there was a practice worksheet that you picked up when you walked in. Okay, questions on what you're doing? Okay, so right now you're working on the 6 problems at the end of the note.